The powerful LED KIPD-140 manufactured by Proton Production Company is a complete prototype of the products offered by the well-known companies Luxon and ProLight. The white LEDs with the power of 1 and 3 watts enjoy the widest popularity. These types of LEDs operate at the forward voltage of 4 volts with a rated current consumption of 350 mA. The devices have the scattering angle of 120 degrees. The LEDs come with a special substrate for the subsequent installation of additional heat sinks. The KIPD-140 LEDs are designed for application in various household lighting devices and in the devices powered by batteries or accumulator batteries. Now let's hold a little experiment using a white 1-watt LED. We will examine the feasibility of using it in a lighting fixture powered off of a battery. For the purpose of our experiment, we will take two R14 cell-line batteries with a capacitance of 2.37 amperes an hour, an accumulator battery with a capacitance of 2600 milliamperes an hour, and a 1.5 volt alkaline battery with a capacitance of 3.1 amperes per hour. The accumulator battery and the alkaline battery will be used with a step-up converter. Let's connect the two batteries with a total voltage of 3 volts to the LED and measure the consumption current. Let's connect the two batteries with a total voltage of 3 volts to the LED and measure the consumption current. It will constitute 140 milliamperes, which is approximately 3/4 of the rated value. The light is a little weaker than normally, but if we calculate the discharge time until the power drops to 1 volt, we can see that the operating set of batteries would be sufficient to support 16 hours of the operating cycle's duration. The calculation is done using a very simple but well-known formula. Let us now connect the LED to the voltage converter assembled according to a simple circuit using the ZZLD381 driver. We then install the 1.2 volt accumulator battery with a capacitance of 2600 milliamperes per hour and measure the consumption current of the entire device. As you see, it is 140 milliamperes, which is acceptable for operation of the LED lamp during night time, although not to the full capacity. However, if we calculate the operation during one accumulator battery, the numbers inform us about 18 hours until the power supply drops to 0.8 volts. Now let's repeat the operation using a 1.5 volt alkaline battery with the capacitance of 3.1 amperes per hour. If we measure the consumption current of 0.75 milliamperes and calculate the LED operation duration with the voltage converter in terms of the operating cycle duration, we will see that actually it constitutes about 17 hours until the battery discharges to 0.7 volts. These experiments were held using low voltages, minimum consumption current, and for the purpose of saving the discharge current of power supply sources. Thus, we also explored the feasibility of using LEDs without an additional heat sink.